Are all the characters unique in a string? Let's find out how to answer this question in a technical interview. The easiest and most brute force way of finding whether all the characters are unique or not is to have two for loops. Our I loop will run from 0 to the end of the string, and the j loop will run from I to the end of the string. So for each I, for example, I is pointing to A, we will use the j loop from B to G to find out if we find A anywhere in the string. Next, we move forward I, which is now pointing to B, and then J, which will now point to C, and will loop through from C to G and see if B exists or not. The same way, we keep moving forward I and J. At any point, if we find a match, we can return false, saying that all the characters are not unique. If by the end of the two for loops we do not find such a match, that means all the characters are unique. So, how do we write the pseudocode for this solution? The first for loop for I runs from 0 to the end of the string. The second for loop for j runs from I to the end of the string. And we keep comparing whether the two characters are same or not. At the end of the two for loops, if we find out that no such characters match, that means all the characters are unique and we can return true. What's the algorithmic complexity of this solution? Since there are two for loops and they are nested, I would say the algorithmic complexity is O of n square, where n is the length of the string. Next, the interviewer is gonna ask you, how can you do better than O of n square? We can use the hash set data structure. We can loop through the string and keep on adding each character to the hash set. Before we add the character to the hash set, we will check if it pre-exists in the hash set or not. So for example, when we are at A, we will check whether A exists in hash set, which it doesn't, so we add it to the hash set. If at any point we see that the character already exists in the hash set, then we can return false. That means our characters are not unique. Otherwise, if we do not find the character in the hash set ever through the whole string, that means all the characters are unique. So, how does the pseudocode look like for this solution? As you can see, we have our for loop which is running from 0 to the end of the string. For each character, we check if it already exists in the hash set. If it does, we return false. If it does not, we simply add it to the hash set. If at the end of the for loop, we do not find the character in the hash set, that means all the characters are unique and we return true. Since the lookup in hash set is just O of 1, the algorithmic complexity of this whole solution is O of n, where n is the length of the string. However, we are using another data structure, the hash set. So the space complexity of this solution is a little bit higher. It's O of n. Well, this is the trade-off that we have. In our first solution, the runtime complexity was O of n square, but the space complexity was just O of 1. Whereas in our second solution, the runtime complexity is O of n and the space complexity has also increased to O of n. As a candidate, you should be able to explain this trade-off to the interviewer. Next, the interviewer might want you to do another solution, something which does not take the space complexity of O of n. The next solution, without using the extra space, is by sorting the string first and then run a for loop where you can compare the adjacent characters. If the adjacent characters match, that means the characters are not unique. Otherwise, the characters are all unique. Here is the pseudocode for the solution that we just discussed. As you can see, we first sort the string, then we run our for loop from 0 to string.length -2. At each and every iteration, we check if string I is equal to string I plus 1. If the characters match, we return false. Otherwise, at the end of the for loop, if no adjacent characters match, then we return true. What's the algorithmic complexity of this solution? Since sorting usually takes O of n log n, and we are running a for loop from 0 to the end of the string, we can say that the algorithmic complexity is O of n log n plus O of n, which is equivalent to O of n log n. So this solution's runtime complexity is O of n log n, and the space complexity is O of 1. So this is what the interviewer is looking for. They just want you to compare the different solutions and be able to explain the trade-off between these solutions. Next, the interviewer might ask you to write the code on the whiteboard for any of these solutions. Before you start writing any code, please make sure to take care of all the edge cases. For example, in this solution, you might want to check if the input string is null or empty. I'll be providing the GitHub link to the actual working code in the description of the video. Please try writing the code on your own before looking at the solution. If you are able to explain all these approaches well in the interview, then I would say that you have successfully answered the interview question. I'll be posting more such interview questions and how to answer them on my YouTube channel. So please subscribe to Coach for Dev for more such questions. Until next time, happy coding!